Let's see what to do in the case of using substitution in definite integrals. So this is what happens. And this is actually pretty nice. I like this a lot. When we have the definite integral from a to b of f of g of x times g prime of x dx, we use the substitution u is equal to g of x, du is g prime of x dx. We replace g of x with u, g prime of x dx with du, and we replace one more thing. We replace the lower limit a with g of a. That is, we plug in x equal to a into here to get a limit in terms to rewrite the limit of integration in terms of u, and we plug b for x into g of x to get what the upper limit is in terms of u. So because u is equal to g of x, when x is equal to a, u is equal to g of a. When x is equal to b, u is equal to g of b. And the nice thing here is once you go ahead and integrate this, you don't have to go back to x. You can just plug these limits of integration in. Fantastic. Okay, so let's evaluate the integral from 1 to 2 of dx over 3 minus x squared. Now when I write dx over 3 minus x squared like this, what this is really supposed to mean is 1 over 3 minus x squared dx. But people just like to write the dx in the numerator like that. Anyways, so when I see something like this, I see a function inside of a function. The inside function is 3 minus x. So that suggests that I want u to be equal to the inside function 3 minus x, even though I don't see a product, even though I don't really see the derivative of 3 minus x floating around. Just because I have a function inside of a function suggests this is the thing to do. And then du is going to be equal to negative dx. And well, I see dx here, not negative dx, so I can put the negative on the du and get that negative du is equal to dx. So this is equal to negative du over 3 minus x is equal to u, so u squared. And I have to change my limits of integration. When x is equal to 1, then u is equal to 3 minus 1, which is equal to 2. Great. When x is equal to 2, u is equal to 3 minus 2, which is equal to 1. Okay. And fantastic. Now I can go ahead and start to try to integrate this. Du over u squared, the best way to try to integrate this is to rewrite this as negative u to the minus 2 du. Just putting this power in the numerator. And the antiderivative of u to the minus 2 is I add 1 to negative 2 to get negative 1. Divide by the new power, which is negative 1. And then this is being evaluated from 2 to 1. It's okay that I've got the bigger number on the bottom, the smaller number on top. It's going to work out just fine, don't worry. Now let's see, minus canceled. I'm just left with u to the minus 1, and I'll plug in my limits. U to the minus 1 evaluated at 1, minus u to the minus 1 evaluated at 2, and that's 1 minus 1/2, so my answer is 1/2. I'd like to make a quick note, which is some of my students really resist or can't seem to remember this idea of replacing the limits of integration when you do the substitution. So here is another thing that you can do. And so we've done our substitution. We get negative du over u squared. If you really don't like this idea of replacing the limits of integration, you can leave them as 1 and 2, but write down x equal to 1 and x equal to 2. This tells you that these limits are in terms of x, not in terms of u. You can go ahead and complete your integration. This is still equal to u to the minus 1. This is going from x equal to 1 to x equal to 2. These here tell you that you need to rewrite things in terms of x first. Since u is equal to 3 minus x, you get 3 minus x to the minus 1. And now you can drop this x equal to 1, x equal to 2 thing, and you can plug it in, 3 minus, and you get 3 minus 2 to the minus 1, minus 3 minus 1 to the minus 1, which still gives you 1 minus 1/2, which is 1/2. You could do it this way, but it's really just a lot faster to replace these guys. But if you don't want to, you don't have to. But I still suggest then you write this notation to remind you to get back to x before you plug in the limits. All right, now let's evaluate the integral from 0 to 3 of 2x over x squared plus 1 dx. This is, to me, a fairly straightforward substitution example, because in the denominator we've got x squared plus 1. In the numerator we have 2x. 2x is the derivative of x squared plus 1. So let's let u be x squared plus 1. Du is equal to 2x dx. There's my du, 2x dx. There's u in the denominator, so we get the integral of, let's write it as du over u, fine. And we have to replace our limits of integration. When x is equal to 0, then u is equal to 0 squared plus 1, which is 1. When x is equal to 3, u is equal to 3 squared plus 1, which is 10. So this goes from 1 to 10, and then we plug in, or we integrate. The integral of du over u is the natural log of u, going from 1 to 10, and I plug in. I get the natural log of, we have the absolute value here, but the absolute value of 10 is 10, so I just get the natural log of 10 minus the natural log of, again, the absolute value of 1 is 1, so a natural log of 1, and the natural log of 1 is 0, so this is just equal to the natural log of 10. Here's question 2. I would like you to evaluate the integral from 0 to pi of cosine of x times the square root of sine of x plus 1.